Let's rewrite special pattern polynomials. Problem number 1. m to the 6th power minus 16n squared. Step 1. Determine if both terms can be rewritten as squares or cubes. M to the 6th power can be rewritten as either a square, m to the 3rd power squared, or as a cube, m to the 2nd power cubed. The second term, 16, can be rewritten as 4 squared, n squared, 16n squared, combined 4n squared. The second term can only be rewritten as a square, not a cube. So that means that both terms can be rewritten as squares. M to the 3rd squared minus 4n squared. How did we determine if both terms can be rewritten as squares or cubes? We determined that both terms can be rewritten as squares. M to the 6th power can be rewritten as both a square and a cube, but the second term could only be rewritten as squares. Step 2. Identify the special pattern type. We have a square minus a square, and that pattern follows the difference of squares. A squared minus b squared. How did we identify the special pattern type? These patterns are either squares or cubes and then the operation between them. So we find the pattern by looking for whether we're dealing with squares or cubes, and then the operation between was a subtraction, so we know that we are dealing with squares, and a subtraction tells us to look for difference of squares. Step 3. Rewrite the polynomial as a multiplication. In the pattern, a is m to the 3rd, b is 4n. So we start with this first parentheses, then a would be m to the 3rd, minus b is 4n, and then we close the parentheses for that first factor, and we start the parentheses for the next factor in the multiplication. A is m to the 3rd, plus b is 4n, and we close the parentheses, and we have rewritten the polynomial as the multiplication m to the 3rd minus 4n times m to the 3rd plus 4n. How did we rewrite the polynomial? We were able to rewrite the polynomial following the special pattern for difference of squares, using m to the 3rd power to replace the a locations and 4n to replace the b locations. You are now ready to rewrite the special pattern polynomial in problem number 2.